The last part of the guide is just sketching polynomial functions. And in sketching polynomial functions, again, it's just a rough sketch. What I'm going to need you to find are the zeros of the function, bless you, the end behavior, so that's reaching back to what we learned back in Unit 1-2, but it's going to help us sketch. And then I want at least 2 other points, okay? So I want to sketch the function y is equal to negative x cubed minus 2x squared plus 7x minus 4. So in order to graph this function, or to sketch this function, I should say, I want to first start off by determining the zeros. How do I determine the zeros of the polynomial function? Rebecca. Okay. So by factoring it, first of all, solving it equal to 0, I should first set it equal to 0, right? So I'm going to set it equal to 0. Again, it's very important because you can't solve it equal to 0 if you don't have it equal to 0. Okay? That's one of the common mistakes people make on tests, and they'll see BF on their paper for bad form because they're solving for 0 when they haven't even indicated that it's equal to 0. Okay? So Rebecca's right. The first thing you do is you try to factor it by grouping. That doesn't work. Then you have to factor it using the factor theorem and the synthetic or long division. Okay? This is just my personal opinion. I never like a leading negative coefficient. So if that's the case, because now I have an equation, I can divide everything by -1. And what that does is just changes the signs of everything. But now my leading coefficient isn't negative. Okay? Doesn't make a difference at all. I just don't like leading coefficients. So now I want to factor this. I try to group it. It doesn't group. So now what I need to do is identify a factor of 4 that will go into it evenly. So using synthetic division, 1, 2, -7, and 4. Again, you're guessing factors of 4, right? And on a test, start with 1, -1, 2, -2, 3, -3. One of those should work. So I'm down by 1, multiply, add, multiply, add, multiply, add. And it turns out that if I use 1, I get a remainder of 0. So when I use 1 up here, what was I dividing my polynomial by? Right. So I've now changed my polynomial, which was this, into x minus 1 multiplied by the quotient, which was x squared plus 3x minus 4. And that's still equal to 0, right? Because all I've done is change the look of this polynomial into this and starting to factor. Now I look at that trinomial, that quadratic. If it factors, I factor it. If it doesn't factor, what would I do? Yeah, use the quadratic formula. But it does factor. It's a very easy one. It factors to x plus 4 and x minus 1. So now that I have it as a product of its factors, to solve for the zeros, right, I set each factor equal to 0. And then I solve. X is equal to 1, x is equal to -4, and x is equal to 1. So in solving for the zeros, that's what I just found. I found x equal to 1 will give me 0 if I plug it in. X equal to -4 will give me 0, and I got 1 again as an answer. Graphically, what did I just find? David. Mm-hmm. Perfect. But you went a little bit further than what I wanted. So what did these guys represent on the graph? Just simply, pardon? And on the graph, what would I call them? Thanks, Nick. The x-intercepts, right? So you're trying to make it harder than what I was actually asking. So these are the 2 places where it crosses the x-axis. So I'm going to graph those 2 points. So it crosses the x-axis here at 1, and it crosses the x-axis here at -4. Okay? All right. No, that's okay to write it only the one time. But when it does equal to a number twice, it's going to do exactly what David said. It's going to come up, hit, and then go down again. So it's kind of important that you know that there's 2 of them there. Okay? But if you just write it once, you don't have to repeat it. Okay? So I've got now the zeros. I want to answer this, the end behavior. Remember that the end behavior means as x heads towards negative infinity, what does y head towards? And as x heads towards positive infinity, what does y head towards? So this is reaching back to Unit 1-2, but everything that you've learned, right, is you're going to see throughout the course. How do I answer this question using the original function? That's important. We're using the original function. How do I answer the end behavior using that original function? Does anybody remember John? Right. So I use the degree and the leading coefficient, which is this guy right here. Then what do I do? How do I use it? Now you told me. What do I do with it? How do I get that? Perfect. Okay. So if you missed what he said, but he did a great job of explaining it, it's just really some mental math. Okay. So if he answered this one first, I'll answer this one first. As x heads towards positive infinity, put a really big positive number in here and cube it. It's still going to be a really big positive number, right? And then once you take that really big positive number and multiply it by the negative in front, it's going to make it negative. That's exactly what John said. Okay. And then he said, because this is an odd degree polynomial, right, they're going to have opposite end behavior. So really, I don't even have to figure the other one out. It's going to go to the opposite side. Okay? But if you forgot that, if you didn't know that, you could still use that mental math. Negative infinity means that it's a really big negative number. A really big negative number to the power of 3 would just be an even bigger negative number, and then multiply it by the negative in front would make it positive. That's going towards positive infinity. Make sense? Okay, so now I know that, now I know that as x heads towards negative infinity, so on this side, my graph is heading upwards, so I know it's going to head upwards up here, and on this side, it's heading downwards, so I know it's going to head downwards over here, so that's going to help me sketch it, okay? So, you're going to pick some other points in order to help you graph this function. Right now, in your guide, I think they have you pick the points in between, right? I don't know if everybody's gotten to that part. You don't have to do that. Just pick any two other points to help you graph it. So I want to pick a value in between here, and a nice value in between there is 0 because that's nice and easy if I plug 0 into the original function, because that becomes 0, that becomes 0, that becomes 0. So my first point on my function is 0 and negative 4. So I went through that quickly. All I'm doing is I'm picking a value for x, substituting it into the original function, and getting my answer. So I know the point 0 and negative 4 is on my function. Now I want you to do 2 points, because on the test I'm going to ask you to do at least 2 points. Okay? If you do 1 point, you're going to get 1 mark. If you do 2 points, you're going to get both marks. If you do 3, you're going to get 2 marks. If you do 7, you're still going to get 2 marks. Okay? So I want you to do at least 2. So if I plug in the value of 2 here, we plug 2 into the original function, and I've already done that for us, and that works out to be negative 6. So 2 and negative 6 is down here. And I know because of the end behavior, it's going to head downwards. So I know what it's doing after that. And on this side, if you're still not sure what it's going to do, you can figure out another point if you wanted to. If you put negative 5 in, it actually works out to be 36. But we knew after this would start to head upwards anyway because of the end behavior. So now you have enough in order just to sketch it. Okay? So as it headed towards negative infinity, the function went upwards like that. Then this part right here, everybody's going to draw this part a little bit differently, and that's okay. Okay? Because you don't know exactly where the turning point is, and I don't want you to figure that out. For those of you taking calculus, you'll learn exactly how to figure out where it turns, but for now you're just kind of estimating it. So if you draw it and have it pass through here, that's good enough. Okay? And exactly what David said, it's going to come up and touch because of the double root, and then head back down. And that's the graph. Okay? So very straightforward, very similar to what you're going to get on your test, right? Is to be able to graph a polynomial function. You find the zeros. Okay, so you factor, you solve for the zeros. Once you have the zeros, graph them because those are your x-intercepts. Figure out your end behavior so you know what they're doing on either side. And then pick at least 2 points. I want to see at least 2 points. You don't have to, you can do exactly what I've done. You don't have to show me your work. You can just list the 2 points and then sketch it. Pretty straightforward stuff. Okay. So